All right, welcome back. We're going to talk about chapter 7.3, which is talking about matrix equations. Now, this is probably the most important one we're going to talk about in chapter 7. So really pay attention. So what is a matrix equation? A matrix equation is just taking, and a lot of times we'll take a system of equations. So I'll take and we'll say negative 3x minus y equals 7. So I take this system of equations and we're going to form it into a matrix equations, which is just multiplying matrices to form with an equal sign in it. So we have, again, our coefficient matrix, which is 1, 4, negative 3, negative 1. We have our variable matrix, which will be x and y. And then we will have our solution matrix, which is there. So this is a matrix equation. So if I multiply these two together, I will get this solution. Well, if I multiply these two, that is that section right there. And our goal, again, like we've been working on, is to solve for this x and y. And how we're going to do that is using the inverse. Okay, this is going to represent this equation right here. So I have ax plus b. Now I can't just, normally we'd just divide by a on both sides and we'd have x. But we have to understand that we can't just divide by a matrix. So in order to solve this equation here for x, we'll have ax equals b, and I'll use capital letters because capital letters are matrices. We're going to have to do the inverse of this matrix. So we'll have a minus 1. Okay. Now over here, since I did it in front, we'll do a minus 1 in front. Now these two will cancel, and I will get x equals the inverse of a times b. Now again, these are two matrices, and I will be able to multiply those together. Now my hope is that a has an inverse. Okay, if a doesn't have an inverse, we can't solve it. Okay, so our goal is to let a have an inverse. In order for a to have an inverse, the determinant cannot be 0. Okay, so we don't want the determinant to be 0. If it is, we can't solve it this way. So most examples, it will not be 0. And then we will just find out what the inverse is and multiply it by b, which b is, this was a, x, and b. B is your answer. Okay, so in this case, we would take the inverse of this and multiply it by that. In order to find the inverse, we need to understand what the identity is. Okay, so if I have two inverse matrices, let's say I have A and A inverse. Okay, they are inverses of each other. Remember what inverses do. Inverses cancel each other out, like plus and minus are inverses. Well, when I multiply two inverse matrices together, I get an identity matrix. Okay, here are some examples of identity matrices. 1, 1, 0, 0, 1, 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, and I could go on forever. Okay, this is inverse 1, inverse 2, inverse 3. Okay, and all that means is that inverses will always be a square matrix, and this is just how many rows and columns it has. Your diagonals will be 1s, and everything else will be 0s. It's kind of like in reduced row echelon form. Okay, so that's the identity. So if I take A times the inverse, I get out the identity. So we're going to use this identity idea to help us find out what this matrix is. Which I'll show you the steps here. So steps to find square inverse. So step one is put into an augmented matrix. We'll have A, and then we will have the inverse on this side. Okay, so instead of having single numbers over here, now we're going to have maybe some kind of square matrix over there. Okay, so step two is get into RREF. So get into reduced row echelon form. And step three will be to check. So if I multiply them, and it should be either way, doesn't matter the order. If I put the inverse first or the inverse second, you should get out the identity. Okay, so those are the three steps. There's a special case with the 2x2 matrix. There's a nice little formula that looks like this. So A inverse in a 2x2 only. Okay. So if A equals A, B, C, D, then A inverse will be in this form. Okay. Now, I'm not going to make you memorize this, okay, because it's just a special formula. I can get the same answer doing these steps. But notice right here is the determinant, okay? And if that determinant is 0, this thing doesn't have an inverse at all because I can't divide by 0. So solving systems with matrix algebra looks something like this. So we will first write we'll write it as a matrix equation. Okay. Which we take our system, we will write it as a matrix equation. We will find the inverse of A. So maybe I'll put here AX equals B. So 2 is find inverse of A. Okay, so you're going to find the inverse of that. That means you are going to find A. You can do this, put A here, put the identity, get that into RREF. And then 3 multiply A inverse times B. And you'll be done. That's what X equals X. Okay. We're really going to use these matrix equations for some cryptography stuff. So if I want to send some code, let's say I want to send, we can send words, we can send numbers. A lot of times, I'll do an example later. We'll send a number. Let's say I want to send the number 2178. Okay, we will code this number into something totally different. Okay, so this might be my code right here. This is called your key matrix, and it will transform it into a different matrix. So I might say that the key might be this matrix. Let's say -1, 5. And then when I multiply it, I get some new matrix with numbers in it. This is the I'm just going to send this string of 4 numbers. So whatever the numbers are. This is what I'm sending, maybe through email or something. The receiver already has that set separate times, or maybe this one's handed to him in person or something like that. And then they have to decode it going the reverse direction. Okay, so we're going to spend a lot of time on cryptography with matrices. So this is not the only way cryptography works, but it's the one we're going to talk about. So this is our stopping point here. So here are your questions. You got 3 of them there. And how do you find the inverse of a matrix? Write the matrix equation to that system. And how do you solve a matrix equation? Let me get the suggested problems here written down. So we're going to be on page 677, numbers 7, 11, 17, 19, 21, 25, 31, 33, 35, 39, 41, 47, 49, 53, 55, and looks like 67 is the challenge problem there. Okay, so if you want, you can go ahead and stop watching. I'm just going to go over some more examples over matrix equations. Okay, so write the first ones we're going to write as a matrix equation. So this first matrix here is just our coefficients. We will multiply that by our variables, and we will write the first variable on top, and then that will equal our solution, which is right there. Okay, now here we need to move those to the other side. So again, we've got A's, B's, C's. So 1, 1, 1, -1, 1, -1, 2, -3, 1. We'll have our variables, which is A, B, C, equals our solutions after they were moved over. So 3 minus 5, 2. Okay. All right, so those are matrix equations. So now we just want to talk about the identity. Anytime we multiply by the identity, I should get back the original solution. So this just wants to find identity of 2 times A. Here's our A matrix. So our identity 2 is 1, 0, 0, 1. Remember, those are square matrices. And then we'll have -2, 3, 4, 7, 1, -1. Okay, so we have we have 1 times -2 and then 0 there. So that's -2. We have 1 times 4, 0 times 7, so that's 4. And 1 times 1, 0 times -1, it's 1. Notice I just took 0 times this whole second. All that canceled out. 1 times this one. So when we go down here, I'm going to take 0 times the top row, and that cancels it all out, and 1 times the bottom row. So the bottom row stays. And indeed, I got back the original. Okay, so here it says verify that the A inverse is this. It just says verify that these two are inverses. Okay, so we're going to take -5, 3, 2, -1, and 1, 3, 2, 5. But we also need to go the other way around. Remember, matrix multiplication is not the same both directions. Okay, it can differ. All right, so when I multiply this, I'm going to switch to a pen here. When I multiply this, I'll get -5 plus 6, which is 1. Then I'll get -15 and plus 15, which is 0. That's kind of hard to see on the camera there. Okay. Maybe. So I'll get 2 times 1 is 2. -1 times 2 is -2. So that's 0. And then 2 times 3 is 6. -1 times 5 is -5. So that's a 1. So I do get my identity matrix back, which is good. But I got to check this one here to make sure I get the identity matrix back. So I have 1 times -5 minus 5 plus 3 times 2 is 6. So that's a 1. I have 1 times 3 is 3. 3 times -1 is -3. That's a 0. 2 times 5 is -10. 5 times 2 is 10. That's 0. 2 times 3 is 6. 5 times -1 is -5. So that's a 1. So again, I do get an identity matrix both directions. So yes, these two are inverses of each other. So we want to find the inverse of this matrix. So in order to find the inverse, we have these steps. So find the square inverse. We're going to put into an augmented matrix. We're going to get our REF, and we're going to check the solutions. So we're going to take this and put it into an augmented matrix with the identity on the other side. Now I'm going to use our REF, or I'm going to use that process to get our REF on this side. I'm basically trying to switch these two. Okay, so this has to be a 1. This needs to be a 0. So we're going to take row 2 and change it, -3 row 1. We're going to put it back into row 2. So row 1 is staying the same. Okay, so I've got 3 minus 3 is 0. 5 minus 6 is -1. 0 minus 3 is -3. And 1 minus 0 is 1. Okay, so I need to get this to be positive. So we're going to take negative row 2 back into row 2. So 1, 2, 1, 0, 0, 1, 3, -1. So now this needs to become a 0. So we're going to take, I'll move up here. We need to take row 1 minus 2 row 2 back into row 1. So row 2 is not changing. So we're going to take 1 minus 0 is 1. 2 minus 2 is 0. We have 1 minus 6 is -5. 0 minus -2 is 2. So there's our matrix. Now, A inverse is now this section over here. So -5, 2, 3, -1. Okay, and we would want to check this. We will check A inverse. Does that equal the other way around? We would want to check that and make sure. In this case, it does check out. And we can do that on the calculator. I'll show you that. later on down the road. We could also use the formula on this one. I'm not going to get deep into the formula because we won't use it very much. So you can also use that if you would like. Okay, let's, before we do that 3x3, let's look at this one. Okay, and we just, sometimes you want to find, is there even an inverse to this? So that's when we'll do the determinant. Sorry, you can't see this. We'll do the determinant. So I get 5, I get 5 here, and then bottom minus the top, which is 0. So since the determinant here is 0, this one does not have an inverse, which would make things difficult later on. Okay, so find the inverse of this one. So we'll write it as an augmented matrix. And then on this side, we'll have the identity. Okay. So then we want this identity, we want the identity over here. Okay, so I got a 1 here. This needs to be a 0. So we'll take row 3 plus row 1 back into row 3. So this row is fine. This row is fine. And we will add these two rows together. So I get 0, 2, minus 3, 1, 0, 1. So I got my 1 and my zeros. Now here I've got my 1 already, so I need to change these two rows. So we'll take row 1 minus double row 2 back into row 1, and we'll take row 3 minus double row 2 back into row 3. Now again, we've done this sort of thing. So again, it's a lot of tedious work, but things are usually really easy. So row 2 isn't changing, so we'll copy it down. Row 1 minus double row 2. So that's 1 minus 0, 2 minus 2. That is negative 1 minus 2 times negative 1. Whoop. So that's negative 1 plus 2. 1 minus 0, 0 minus 2, 0 minus 0. Then row 3, you'll take 0 minus 0, 2 minus 2, negative 3 minus negative 2, which is minus 1. 1 minus 0, 0 minus 2, and 1 minus 0. Okay, so column's good, this column's good, this column. We need to change the sign of everything in the bottom row. So negative row 3 back into row 3. Everything else is staying the same for now. Okay, so this is good. These two have to be 0. So we'll take negative or row 1 minus row 3 back into row 1. And we'll take row 2 plus row 3 back into row 2. So row 3 is not changing. Okay, so row 1, we're going to subtract row 3. So 1 minus 0 is 1, 0 minus 0 is 0, 1 minus 1 is 0, 1 minus negative 1 is 2, negative 2 minus 2 is negative 4, and 0 minus negative 1 is 1. So then here we get 0, 1, 0, we're just adding. So 0 plus negative 1 is minus 1. 1 plus 2 is 3, and 0 plus negative 1 is negative 1. So here is our inverse of that matrix. So if I take these two and multiply them back together, we will get the identity back out. So this is what you're going to have to find in order to solve your systems. So we first want to look at this system. So we'll take this and write it as a matrix algebra or matrix equation. So we have 1, 1, 1, 1, 0, 1, 1 minus 1 minus 1. My variables are x, y, and z. And my solutions are 2, 1, 4. Okay, now in order to get this to the other side, we have to find the inverse of this. So we will take that matrix, put it into an augmented matrix with the identity, and we will find its inverse. Okay, then we will multiply it by this. So the inverse. So this is a 1, so I got to change these two to zeros. So R2 minus R1 back into R2, and R3 minus R1 back into R3. Row 1 is not changing. So I have I have row 2 minus row 1. So 1 minus 1 is 0. 0 minus 1 is minus 1. 1 minus 1 is 0. 0 minus 1 is minus 1. 1 minus 0 is 1. 0 minus 0 is 0. Then row 3 minus row 1. So 1 minus 1 is 0. Negative 1 minus 1 is negative 2. Negative 1 minus 1 is negative 2. 0 minus 1 is minus 1. 0 minus 0 is 0. 1 minus 0 is 1. Okay, so this needs to be a 1. So we'll take negative row 2 into row 2. Okay, so this is a 1, so this needs to be a 0, and that needs to be 0. So row 1 minus row 2 back into row 1. And then row 3 plus double row 2 back into row 3. So row 2 is not changing. Okay, so row 1 minus row 2. So 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 0 is 1. 1 minus 1 is 0. 1 minus negative 1 is 1. 0 minus 0 is 0. So row 3 plus double row 2. So that's 0, 0, negative 2. Negative 1 plus 2 is 1. 0 plus negative 2 is negative 2. And 1 plus 0 is 1. So this right here, this here needs to be a 1. So we'll take negative 1/2 row 3 back into row 3. Looks like we'll be getting some fractions here. So this is negative 1/2. This is 1. This is negative 1/2. And this has to be a 0, so we'll subtract. So row 1 minus row 3 back into row 1. Okay, so row 1 minus row 3, so that's 1/2. That's 0. And row 1 minus, that's 1/2 too. Okay, so here's my inverse matrix right there. So now that I have my inverse matrix, we're going to take the inverse matrix, times B, which was this solution right here. And my solution matrix should be in the same matrix form as this one. Okay, so I had a half, 0, a half, 1, minus 1, 0, and minus a half, 1, minus a half. Okay, so I have a half. So a half times 2 is 1, plus 0. Half times 4 is 2, so that's 3. So I have 2 minus 1 plus 0, so that's 1. I have a half, so that's negative 1 plus 1 minus 2. So that's minus 2. This should be a negative 4. I failed to write that down. Minus 4 there. So that's a minus 4 there. So this is a minus 2. So that's a minus 1. And this is a positive 2. So this is a... So negative 1, 1, 2. So that's a 2. So X, Y, Z matrix equals negative 1, 1, 2 matrix. Okay, and those are your solutions. Now, encryption is similar. So what we'll have here is suppose you want to send your ATM PIN to someone through email. You will want to encrypt this PIN so that no one knows what it is except the receiver. So this is my PIN here. So I'll put that in a matrix. Okay. And I will have a key to this matrix. Let's just say I pick negative 2 and 1. That's my key. So I'm going to multiply those two together and get this matrix. So 2, 2, 7, 4, negative 2, 1. Okay, so we'll multiply this. Whoop, I can't do that. I had it right the first time. Okay, so let me just rewrite this. Okay, so we'll multiply this. So you get negative 4 plus 2. Hold on. We'll simplify this. So we want to send 27. So we're going to say 2, 7, and we're going to have a key, which will be a square matrix. That way square matrices have inverses. Okay, so let's say we're going to have our key to be 2, 3, 5, 8. Okay, so we'll multiply these two together. Okay, so that's 4 plus 35. That's 39. And then we have 6. 56. So that's 62. Okay, so this is the number you are sending. So if I'm the receiver, this is what I get. I know that this is the key, okay, but I need the inverse of the key times what they sent you. Okay, so to find the inverse of this key, let me come up here. We'll have 2, 3, 5, 8, 1, 0, 0, 1. We will do the RREF on that. I'm going to kind of save some time here. And the RREF on that will lead to this. Again, this is 2 by 2, so we've got that special formula you might use on that. So then I'll take this matrix times this one here. So that's 8 minus 3 minus 5, 2. Whoop, I did it backwards. We put the key up here. And then this should be 39, 62. So if I multiply those on both sides, I'll get back 2 and 7. Okay, we're going to spend quite a bit of time on this encryption stuff. It's pretty neat the way it works out. So here are your suggested problems and your questions. Again, we're going to spend quite a few days on this topic. So if you got questions, let me know in class or come in before or after school. As always, this is at THS Mr. Jones signing off. Thanks for watching.